Okay, so last time we were looking at our sample data coming back from Blockchain.info, which looks like this. And let me just reload this page. So this is getting us data from a single address, this guy, which should give us the hash, the address, the number of transactions, total received, total sent, final balance, which we really can't use for our example since there might be multiple payments going to multiple votes, if you will, going to the same address. Here, I'll blow this up a little bit. And then we finally have an array of the transactions. All right, so that's what we had, well, somewhere in here, but we were programmatically looking at it in here, where we said, go ahead and let's read in from the URL. Let's get the entire JSON string into this string called result. We printed that out to prove that we were able to get that JSON string. So inside result, we essentially have this whole page. Everything that came back on this page with all these crazy JSON crap. Okay. Then we use our simple JSON library that we worked with last time to parse that JSON string, and that gets us a top-level JSON object. And we know it's a top-level JSON object. Well, we know it's a JSON object because it starts with an opening curly brace, and I promise you it ends with a closing curly brace. So that dictates that it's an object, not an array. Okay? So we're going to store that inside of this JSON object called obj. Then we want to extract that array of transactions. So this thing called TXS, this guy right here, that from the documentation here is this guy. So that's the variable. Its value is an array of transactions. So that means it's going to be an opening square bracket and a closing square bracket. And inside here, there will be a transaction. Well, a comma delimited list of transactions, I guess. So here's our array called the transactions. We went ahead and we printed out that whole thing of transactions, which just looks like JSON, right? Then we're going to go ahead and we're going to go through each one of those transactions. We're going to get the JSON object from it. Now, when we pull it out of transactions, it's going to come out as a I can show you here the transactions dot. So get at a particular bucket. So if I want to get the first transaction, I would say get at bucket 0. Notice it returns for me an object. Okay, not a JSON object. Okay, so it's going to give me a generic object. Therefore, when I spin through all the transactions in here with this for each loop, each thing that's going to come out is an object. Now I happen to know that it's actually a JSON object. So right here I'm going to cast JO from a generic object to a JSON object. So right here I get that JSON object. Then I'm going to get the value associated with something called out. Okay, and we'll look at that here in a second. Out should be an array. We'll go ahead and store that in a variable called AR, and then I was printing out AR size. So we were trying to figure out what that out variable holds, and I don't think, actually this might be a good way of seeing it. It's a single block. Here's a single transaction. So a single transaction has all this information in it. We have inputs, which is an array of stuff. So here's our inputs. Then we have out, which is the variable we're grabbing right now, which should be an array of stuff. Here's one of the things. Here's another thing that's in there. So the question is what is each of these things? To me, that looks like a transaction amount. But are these in or out? So we're trying to figure out how their API works. Ultimately, and let me show you this real quick for a single address. Ultimately, we should have this many transactions, and if we were to add up, we'll add and subtract all the incoming and outgoing transactions, we should get a final balance of whatever that number is for us. So in our particular example, if I want to get final balance, all the way up here, I can do system.out.println final balance concatenated with obj.get final balance. And then this guy should give me the final balance for my account, which was that. And this is in Satoshis. So that's 0.00000001 Bitcoin is a Satoshi. 7 zeros and a 1. I think that's right. For 8 total. I think that's right. So that's what the final balance should be in Satoshis for my particular thing. Each of these are our transactions, and all I'm printing out right now is the length of those array sizes. We need to figure out what those internal pieces are. We need to understand the JSON so that we can add and subtract and ultimately come up with that number. All right, so what we want to do is look at these values. So let me quickly do this. Let's do AR. Well, here. Let's just print out AR. We should see a bunch of those transactions instead of AR size. It's cooking. Okay, so here's what each of those transactions look like. Here's the value portion of the transaction. Here's the address portion. Here's the transaction index. I have no idea what the script thing is. Probably some sort of internal Blockchain.info thing. Type is 0. They look like many of them are 0. Spent is true. We might be interested in knowing whether true means that something went out, false means something came in, but I'm not sure. Then internally, we have another object. This other object has a value associated with it, an address, transaction index, a script. Spent is equal to true. Now this is interesting. We have spent's true, spent's true, spent's false, so it is going back and forth here. So for example, if we are going to compare this to our transactions internally, we have true, true, false there. So this is a number. If we treat these as a number of Satoshis, this is spent, this is spent, this is not spent, this is false, whatever that means. So let's go into Blockchain.info and actually look at our 17 transactions. And actually just real quick. Just print out the number associated with the transactions. So that's the number of elements inside of our transactions array. So I'm hoping that's 17. That means we're looking at the right stuff. 23 even though it said we had 17 total transactions. Okay, well, we'll call that close, so there must be some fluff in there that means something else. So what we want to do is now go into our wallet information here in Blockchain.info. We're going to look at this guy's interpretation of our transactions. All right, so let's look at the transactions. All right, so this should be our 17 transactions.
The spent and unspent seems to mean like you can follow it to the next location if it was spent, and then if it's unspent, it's still sitting in that wallet.
What do you mean follow it to the next location?
So follow it to the next wallet that it's gone to, and then so you can follow it along the Bitcoin line.
Or through the blockchain?
Yeah.
Okay, so wouldn't that then also mean that spent being true means that we sent it someplace else?
Yeah.
I mean, because that means that it's back out in the blockchain, right?
Yeah. It's just built into the Blockchain.net
Info?
Blockchain.info.
So that means that if this is true, we should have two separate transactions that both have a spent of true?
Yeah.
I mean, I saw more than two right off the bat.
It's built into their transaction thing,
So it's like an internal variable for them? It has nothing to do with the blockchain itself?
No, it has nothing to do with the blockchain.
Okay. Well, we'll try to give some value to some of the different things they have in there. So if we just kind of look through these, here was 0.01 Bitcoins coming into the account. Here was negative 1.1 going out of the account, 0.01. So this must be in reverse order, right? Yeah, it is. So 426, 427, yeah. So here was the original transaction. So the account originally was funded with 0.035 Bitcoins. Then it got 0.01, 0.01, 0.01. So this was payments from Bitcoin mining. Then 2 Bitcoins, then 4 Bitcoins, 5 Bitcoins, 4 Bitcoins. Then I transferred 15 Bitcoins out. All right. And then we had some more come in, some more go out, so on and so forth. All right, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So where's that 17 from? That's an excellent question. Was that like one of their example things? I'm just picking 17. It is. I tell you, people, I'm losing it these days. Haven't you noticed in like the last 2 weeks I'm more foggy? I mean, I know I'm always crazy, but like, I don't know. I didn't used to make stupid mistakes like that. It's more of a Caruso thing. All right, so yeah, this was our example number of transactions. My specific account actually has 23 transactions, which then makes our code that I originally said was close actually accurate. Okay, so we're looking at the right crap. Okay, these are the individual transactions. Now we need to pull these guys apart until we can find which pieces of those transactions relate to amount spent, things like that. Okay, so my guess is there's going to be an amount spent and then also a balance somewhere in there. So let's look at a couple of those things here. For that very last one, let's see if we can get something out of this, like a date or something that we can translate it to the actual So these look like all validations or something. Just out of curiosity here, if I have a JSON object, I want to know if this guy gives us the ability to see all the keys. Key set maybe. Let's assume that's a yes. All right. So right now we're actually printing out an individual dude here. What I'm going to do is I'm going to create we already have our JSON object. I'm just going to repurpose this real quick. So inside of this loop, we're going to say obj is equal to AR at bucket. Well, actually, it's just going to be equal to JO, the current object from that transaction. And this is going to be a JSON object. So in the end, obj, we're just setting that variable equal to it every single time through. So in the end, obj should be equal to the very last transaction. Very last one. All we're trying to do here is get all the different variables associated with it and try to match it up to what they're giving us in here. So we can just get some meaning from it. So after this is done, obj should hold the final transaction. So now we're going to do actually I need to do something here, obj.get, no, is it key set dot Okay, we got a to array that gives us an object array. So I'll create an object array called the keys, set equal to this guy. So my hope is that I'm getting all the variable names associated with this, which would match up to something like, not for this exact thing, but something like #160 address, NTX, N unredeemed, total received, total sent, final balance, the variable names only, not the values associated with it. I just want to see all the variables that this guy's keeping track of, and hopefully we can, if they use good variable names, connect the dots to what we have over here. Okay, we know we're looking at our 23 transactions. Now we just need to understand what the individual parts of those transactions mean. Okay. So the hope is these are our keys in an object array. So I'm just going to say for object O in the keys, system.out.println O. Let's just see what that looks like. Okay, I'm not printing out. I took all the other print statements out of here. So basically all this code just goes through. This loop is kind of a waste of time, except that it ultimately sets object equal to the very last transaction. And then we're going to try to look at the variable names associated with that very last transaction. So transaction number 23. And let's see what this spits out for us. Okay, so we have result, block height, time, vout size inputs relayed by hash, vin size, tx index, var out, and size. Okay, now out, I believe we were showing the out variable here, right? Which was another array. So out seemed to have our actual transactions in them. So let's look at that now. So we're going to create a JSON array, call this the outs. And we'll start this guy off at null, just so it doesn't scream at us. And then inside of here, instead of setting our object equal to that, we're going to set the outs equal to AR. So when this is done, now the outs should hold the final transaction. Should hold the out key of the final transaction, which is an array of transactions. Now what I'm going to do is I'm going to get the outs dot get 0. So let's just get the very first part of that. And we know that this guy is a JSON object. I realize we're kind of going all over the place here, but we have to kind of programmatically discern their API because their API is crappily documented. So we're going to go to our collection of outs, which is an array, get the very first, let's call that transaction from that guy, convert it back to a JSON object, because it's going to come out as just an object, get the key set from that object, convert it to an array, and print out all those variable names. So the same thing we did before, except instead of doing it at the top level for the JSON object, we're going specifically to the out variable, which is this guy. And we're getting the very first object from that out variable, like what I have highlighted here, and we're printing out all the variables in here. I think we have more than just these three based on what I saw as we went through it. So I want to see what these variable names are. If it just says value hash script, then this documentation is accurate but really tells us nothing, but I think there's more variable names in it than that. So we're grabbing the array associated with out, then we're grabbing bucket 0 of that guy, which is a JSON object. Then we're grabbing the list of keys, which should be value, hash, script, and hopefully others. Then we're printing out all those keys. That's what our code does right now. So the outs is the out variable associated with our final transaction. Here is the object at bucket 0, the JSON object at bucket 0 of outs. Here's the key set associated with that. Convert that to an array and store that into an object array called the keys, spin through it, print out all the variables. Let's see what we get from that. Okay, did get more than 3, so that's good.
Yeah,
So
but it didn't get the 3.
who?
Missing the hash.
Well, I'm actually okay with that because I actually suspect that this documentation is old. That's my suspicion. So I don't even care about this hash because, first of all, we don't know what it is. But secondly, we don't need it. But as I suspected, there's more crap in there than it was advertised. So we have this n variable, this value variable, this address, transaction index, script, type, and spent. So we're probably interested in value. Let's print out value, address, type, and spent. Actually, let's just print out all those. We can do it while we're in here. So actually what I'm going to do is I'm going to say JSON object the outs obj 0. It's going to be this guy. Then we're going to use the outs obj 0 to get the key set. And then O is each key. So what we're going to do is we're going to print out dot get O. And why don't we go ahead and print out O as well. So this should, just for that very first transaction of the outs, this should give us the name of the key, a colon, and the value associated with it. So let's see what those are for this particular guy we extracted. So we got an N of 0, we got a value associated with it, we got an address, transaction index, a script, the type, and a spent. Let's go ahead and use this address here and see if we can find this in the detailed section of our blockchain. So that's back into the wallet, this guy. And we'll go to my transactions. And right off the bat, let's just do a find here. Paste that in there. Didn't find anything related to that. So let's go to this final transaction. This guy. Let's do that search again here. We have one match. Very top one. So this was the very last transaction. This is in the list of validations. Is that right? Okay, so this guy should have a point 106507. 0.10650723. So that's the Satoshis. So that's matching up. So we're looking at the right piece now. You're kind of seeing where we're going with this? It's like playing Sherlock Holmes. We're extracting piece of information from garbage over here and trying to line it up with what we have over here. All right, so for this particular Bitcoin address, so this was total received from the address, which is 7.88. And only one of those transactions was this guy. And that was from, I'm having problems seeing where this is all coming from. BHP. It's not us. Okay, so here's that transaction, this guy down here, where we had 0.035 Bitcoins come in. Now when I clicked on this, it said there was 2 transactions. So we should see a 1AB somewhere else in here, I think. I'm following this correctly. And I don't. Perfect. It said there was 2 transactions for a total of 7.8 Bitcoins. Here's the transaction hash.
There are 2 transactions there. The top one that you're on right now, and then below that, that's Let's do an oldest first.
Right, but what are these individual pieces? I get that they add up
Yeah.
to negative 7.88. But if you go back to right before that, we were looking at this. The transaction we clicked on was this guy, which should be 0.036 Bitcoin. So if I click on this address, that's the to from. This should be the from because it came to us, right? So if I'm looking at this address and I click on that, this is the transactions associated with this particular address. So not necessarily what's coming into our account. Okay, so this is us viewing the blockchain and seeing the one of the dudes that paid us, this is the wallet address that paid us, we can see the other transactions that came to that dude. So we can see that these, so this isn't our transactions. This is that person receiving, well, down here they received all these Bitcoins, 7.88 Bitcoins from this dude, also not us. And then this person also on the blockchain sent out several transactions to different people until they emptied their account. So what we're looking at here is not one of our transactions, but transactions of one of the people that paid us. That make sense? Okay.
So you can actually find your transaction within those 6 transactions there.
Right, but we shouldn't, I'm guessing we're not looking at the right.
Your 0.036 is there, isn't it?
This guy.
Yeah.
So that must be to us. S9QS. S9QS. Yep, that's our address. So our address was one of the several transactions that came in to this guy. So this was to us.
One more.
Sorry, this was to us. It'd be nice if this one was to us. More monies. Okay, so this one was to us. So look at that. 7.7 Bitcoins at the time. That was 3,500 bucks. 7.7 today times 400. It's not too bad. It's still 3,000. Okay. So, is this the only way for us to pull these transactions out? I suspect not. We could get it that way. We can go in, look at all the transactions associated with all the addresses associated with all of our transactions and pull out the pieces that went to us or that we sent to. So if I just look at, go back to this real quick. I'm going to go to here. This is the address that that guy came from. So if I just go through and I print out all the addresses, does that mean when we sent Bitcoin to somebody that our address is over here on the left? No, that's who we sent it to. That's who we sent it to. See, I want to get these individual amounts. So right now, as far as we've seen, the only way we can get this value right here is by looking at the blockchain associated with the address of the person who sent it and see that he sent us that. But it seems like we should be able to view our own, but maybe not. I mean, this is looking directly at the blockchain. So that means if I look at my own address on the blockchain, let me grab my own address here. We should see pretty similar data. So that's my own address. Okay, so number of transactions is 23 associated with this particular address. And we should see all of these individual it still seems like if we have 23 and we were getting 23 printed out for the number of transactions up here, this guy, the transactions.size, did we have transactions at bucket? Did we ever print out the values associated with an individual transaction? We did, didn't we? Almost positive we did. That's going to give us a big... All right, so let's get rid of those. Well, change the variable name here. So we want transaction 0. And this guy is going to be from the transactions. I think we already did this. I just want to see it again. Now that we've started to connect some of the dots. So I'll get bucket 0 from our list of 23 transactions, which should be that very last transaction. And then I want to get the keys associated with that transaction, and I want to print out all the keys for transaction 0. And let's just see what that looks like, which we've seen before. Okay. We have a result, a block height, a time, v out size. Here's inputs. Where did this guy come from? So we know where outs is from. So let's see if we can figure out where. These are my transactions. Okay, so that's bucket 0. All right, so far so good. So this was from inputs. At bucket 0, there's an amount there. So here's all of those. Is it going to add up to the final number down here? Minus 24. Oh, this is actually an interesting thing. So notice this minus 24 number. It's pretty close. 25 new Bitcoins born every 10 minutes. So this is for a reward from a winning of a block. So there must have been overhead that went to the pool itself. Okay. So we're one of these addresses in there. Fine. So this guy must be the address of the pool that sent us the coins. So whatever pool that is. Then let's see. So we go back here. Yeah, there's the value. That's the 24 Bitcoins total that was sent from that guy, 24.6 Bitcoins that was sent. That's the address it was sent from. Yep. So as far as I can tell right now, we are not able to see and where did this come from, this guy? That's this guy right here. That's the outs. All right, so to connect those dots, the in was this. Sorry. The in is this very first line here, this guy. But we don't get the amount and stuff. So we get the address associated with in, and we get the total amount that was sent from that guy. So if I click that, that's the address. If I scroll all the way down, we get to that 24. Okay? That's this number from our ins, the inputs. So there's the address. There's the total value sent from that address. Okay? So this is the guy it came in from. Then this guy should be the list of all the outs from the ins, of which we're one of them. So the very first out was this guy, this 12 VA, and it should be a value of 0.01 Bitcoin. Is that right? No, should be 0.05 Bitcoin for the very first one. Yep, so 0.05 Bitcoin sent out to that address. Somewhere in here will be our address. It's going to be one of these 0.01s. Okay, so for each of those transactions, we need to look at the if we are in the inputs, which we would be, let's look at this transaction right here. So if I'm looking at this value right here, so that's bucket 1. Let's print out bucket 1 in our code real quick. So that should be something where we paid a bill. We sent somebody Bitcoins. Okay? We should see ourselves in the input with the total we sent as that 1 point whatever. Okay, this is our address, right? Almost positive. Just double check it real quick, just for sanity's sake. So our address ends in S9QS. Yep, S9QS. So this is our wallet address, and we sent this many Bitcoins.
Satoshis.
Huh? Yes, Satoshis. That'd be awesome. There's this many Bitcoins.
Not if you sent them.
That's true.
That would suck if you sent them.
That's true. Now we need to start manipulating the blockchain. How much is that worth? Times, what is it, 420 today? 6.4 million? Billion. 6.4 billion. $6.4 billion. Chump chains. Chump change. Okay. So we're on to something here. So we're in the inputs because we sent something out. So we find ourselves in the inputs. We know that we sent something out. Otherwise, we can find ourselves in the outputs. So if we find the address that we're interested in the outputs, we can get the value of that transaction. Does that make sense? So we should be able to go through and Notice every single time we find ourselves in the outs, which is this address right here, and print out the value of that transaction. So for each transaction, if we're in the outs, display the number of coins that came in, right? For each transaction, if we're in the ins, the inputs, display the value of the transaction that went out, that we sent out. So this is how we're reading the data. So ins is who sent it, who sent the coins. Inputs is who sent it and how much they sent total. Outputs is who received it and how much, the individual ones. So think about this from a blockchain perspective. If we're writing a wallet, we'd have to go through those outputs and find the coins associated with our destination address, the ones that were meant for us. Okay, otherwise we'd be saying our wallet has all these coins in it when it really doesn't. And we can write a wallet that shows you have more coins than you want, but it won't work when you go to the blockchain to write stuff. Make sense? All right, so I think we have some decent information. It would have been nice to be able to just grab the top level. Like, why do I have to parse through all the outs related to a single transaction? Just while I'm thinking about real quick, and we're done, but I'm sure that I sent myself some Bitcoins at some point. This was probably from me. So this must be one of my other wallet addresses, probably my Coinbase. This is probably my Coinbase address. And I sent 5 Bitcoins here to us. And then I sent 0.0009 Bitcoins in that same transaction. This was a transaction fee. So Coinbase charged me this on transaction of this. That make sense? I'm pretty sure that's what's going on. So this destination address is probably Coinbase's just destination, or something along those lines. Okay, so I think we figured out some stuff. We'll come back Friday and pick it up from there.